Counters. Counters are one of the most useful parts of a digital system. A counter is a sequential circuit that holds the ability to count the number of clock pulses provided at its input. The output of the counter shows a particular sequence of states. This is so because in the applied clock input, the intervals of the pulses are known and fixed. Thus, can be used to determine the time and hence the frequency of the occurrence. An arrangement of a group of flip-flops in a predetermined manner forms a binary counter. The applied clock pulses are counted by the counter. We know that a flip-flop has two possible states, therefore, for n flip-flops, there will be 2n number of states, and permits counting from 0 to 2n-1. Counter are of two types, which are asynchronous and synchronous counters. Here in this section, we will discuss asynchronous counters. Asynchronous counters are those counters which do not operate on simultaneous clocking. In asynchronous counter, only the first flip-flop is externally clocked using clock pulse, while the clock input for the successive flip-flops will be the output from a previous flip-flop. This means that only a single clock pulse is not driving all the flip-flops in the arrangement of the counter. Asynchronous counters are also known as ripple counters, and are formed by the successive combination of trailing edge-triggered flip-flops. It is called so because the data ripples between the output of one flip-flop to the input of the next. The figure shows the circuit diagram of a 3-bit asynchronous counter. Here, as we can clearly see, that 3 negative edge-triggered flip-flops are sequentially connected, where the output of one flip-flop is provided as the input to the next flip. The input clock pulse is applied at the least significant, or the firstmost flip-flop, in the arrangement. Also, logic high signal, which is 1, is provided at the J and K input terminals of the flip-flops. Therefore, the toggling will be achieved at the negative transition of the applied clock input. Thus, we can say an asynchronous counter counts the binary value according to the clock input applied at the least signal bit flip-flop of the arrangement. As you know, the asynchronous counter are used in applications where low power consumption is required, and asynchronous counter are also used in frequency divider circuits, ring and Johnson counters. Want to know further exploration about asynchronous counter? In this lesson, you will digging more about the types of ripple counter, its details operation, and also their timing diagram. The more interesting, you can learn more together to build up ripple counter circuit in our instructional video. Further, to empower your understanding, you also can test your knowledge, discuss with other learners, and finally, you can get the completion badge after you finish your lesson. Happy learning!